Our presentation is on micro laser welding, and we have some footage from filer micro welding on the process and some examples of how it's done. Welding is the process of joining two pieces of metal together by causing coalescence. There are a number of different energy sources that can be used to weld metal. For instance, there is gas fuel welding. The most common form of gas fuel welding is oxy-fuel welding, which involves the combustion of acetylene and oxygen. This is one of the oldest and most versatile processes. However, the flame causes slower weld cooling, which can lead to greater residual stresses and weld distortion. Another method is called electric arc welding, which uses electrical energy to create an arc between an electrode and the base material to melt the metal. But this type of welding requires a filler and a shielding gas. Electron beam welding uses a beam of high-velocity electrons to melt the metal. The beam increases the kinetic energy, thus increasing the heat to melt the metal. Unfortunately, there is a high speed of cooling with this method that can cause cracking and other deformations. Another method of welding is by passing a current through the resistance or point of contact between two pieces of metal. The pieces will heat up and create a pool of liquid metal which can solidify. However, the applications are somewhat limited for this method and the equipment can be costly. Laser welding is a process that uses a beam to concentrate the heat at the welding point to attach the pieces. It is useful for narrow and deep welds. However, this method is not applicable for small spot welding. A type of welding that is excellent for small spot welding is laser micro welding. Laser micro welding is fundamentally the same as laser beam welding, but on the micrometer scale instead of millimeter scale. Being on such a small range allows for tight operational tolerances in welding of thin and delicate materials. Now we'll hear from the faculty at Filer Microlaser about how micro laser welding works.
Micro laser welding allows us to repair damaged areas of the smallest size. We can create a bead of weld as small as 0.02 of an inch wide, yet also do large buildups when the situation is called for. One of the main advantages of laser welding is the extremely small heat-affected zone around the weld. This allows us to repair a weld in the middle of a detail with no distorting or warping of the surrounding areas, which is typically the problem when using other types of welding processes. Precision production laser welding is a fast-growing part of our business. With our CNC laser welder, precision welds are easily made from large to small. This has proven to work very well for the production of sensors and medical instruments. Fusion welding is best used in the automated process. Here's an example of our CNC capabilities.
As you can see, micro laser welding offers a very precise act of welding.
Now we will show you a video of a more up-close, easy-to-see representation of laser micro welding. This type of welding is generally done under a microscope due to the small size of components involved. Microlaser welding offers some significant advantages over other types of welding. The first is its ease of automation, which allows it to be optimized for high-throughput operations. The small size of the components also allow for great accuracy and precision of welded components. The focusability and controllability of the laser radiation is what allows for this accuracy and precision. Microlaser welding allows for the ability to deposit exact amounts of energy in well-defined spaces due to the ability to control this laser radiation. One of the best advantages that it offers is that there's no filler material required, as is required with many other types of welding. The laser beam can also be transmitted through air without the requiring of a vacuum or a gas shield, reducing the complexity of the overall system. It has a couple of disadvantages also, however. There's a high investment cost to obtain the equipment necessary to carry out microlaser welding. Additionally, there's a high maintenance cost associated with this equipment. Applications are restricted to the micromolar scale, and if a larger scale is necessary, another type of welding will need to be used. There are currently several commercial applications for using microlaser welding. The first is for the biomedical device industry. As you can see in the picture in the lower right corner, the welding seam on this case for a pacemaker was used using laser micro welding. This type of welding can also be used for catheters, cannula, and surgical instruments. The aerospace industry also benefits from microlaser welding. As you can see in the new picture on the bottom right, the packaging for this electronic system was created using microlaser welding. There are other industries that utilize microlaser welding, such as the semiconductor industry. The future of microlaser welding is based in research to increase the process efficiency. This is mainly performed by increasing the Peclet number, which is directly related to the heat dissipation of the process. The Peclet number is defined as the feeding rate multiplied by the weld seam width divided by the thermal diffusivity of the material used. The Peclet number should always be greater than 1 in order to reduce the heat dissipation losses associated with the overall process. Companies can utilize this information, such as filar microwelding, in order to increase their process efficiency and decrease costs. This increase in the Peclet number can be obtained through 3 different methods. One is to increase the feeding rate. Increasing the rate up to a rate of 6 meters per second increases the process efficiency continuously up to this limit. Additionally, increasing the focal diameter of the spot size can decrease the lateral heat dissipation. Finally, decreasing the thermal diffusivity of the materials used will help increase the process efficiency. Therefore, throughout the design process, it should always be kept in mind to minimize the K value of the materials whenever possible. Using these tips, any company can help increase their process efficiency, decrease heat dissipation, and obtain an overall better process.